Hello everybody, we are today going to have a look at some trigonometric functions. When I first thought of teaching this to you, I wasn't expecting to be doing it in a virtual environment, so there's quite a lot to learn here, but we're going to have a go at this and see what happens. So first of all, let's talk about the sine ratio, right? You should know already that the sine ratio, or sine of theta, is going to be the opposite over a hypotenuse. Now, what I'd like to try and do is to superimpose this onto the x and y axes, right? And let's think about triangles on that plane and see what happens. So imagine a triangle here, right? Okay, or a straight line there, and we're going to say that length is 1, right? Okay, and we can create a little triangle, and let's call that theta. Now, we can do that because it helps us to start thinking about what values the opposite over hypotenuse is going to take for various values of theta. So first of all, let's imagine that we move that line right flat against the x-axis. So if that was the case, well, theta is going to be therefore equal to 0. And if we think about the opposite over the hypotenuse, well, the opposite in this picture is really the height of that triangle. So that height of the triangle actually corresponds to really the y coordinate or the y-axis. So if that line is flat against the axes there, that opposite is 0. So we're going to have sine theta is equal to 0 over 1. So if theta is 0, sine theta is 0. Now, imagine that that line actually moves, and it moves up, and it's moving in that direction. It moves there, and then it moves up to there, and then up all the way until it is flat up there, look, okay, nice and tall. Well, that would be when theta is 90 degrees. And so what would the sine of theta be there? Well, if we think about it there, sine theta at this point, well, that opposite is that y coordinate, right, that y-axis. Well, that's going to be 1. The hypotenuse is going to be 1 too. So therefore, at 90 degrees, sine theta is equal to 1. And you can check this on your calculator. And obviously, all the way between those 2 points, here and here and here, we are getting larger and larger and larger. And that is because that opposite is getting larger and larger and larger, because that opposite corresponds directly to the y-coordinate. Now, the nice thing we can do now is we can actually go past 90 degrees. So we could have our angle of theta being maybe 120, maybe 140, maybe all the way over to 180. Now, we have to work out now what is that opposite over hypotenuse going to be. So let's think about it at 180 degrees. Well, again, if we are at 180 degrees, then really we have that opposite of 0 again, because the opposite is the y coordinate, right? We've got a little tiny opposite if we were at this point, and if we go to there, it's even smaller. So right at 180, again, we can say that sine theta is equal to 0. Okay, now what we could even do, go a little bit further, is we could plot this on some axes. So rather than have an x-axis, let's have a theta axis. And so we could mark some points. So we know that when theta is equal to 0, sine theta is equal to 0. We know when theta is equal to 90, sine theta is equal to 1. And obviously between those 2 points, as we moved up through this angle, we got larger and larger and larger. And then as we went towards 180, here, the sine of the angle went down slowly until at 180 degrees, it was at 0. So if we were to plot it so far, that's what it looks like. Okay, now then, if we move on and we imagine our sine of theta now going even further than 180 degrees, so over here somewhere in the third quadrant, right? Well, first of all, what is that opposite going to be? Now, it's going to be a negative number, because if we superimpose this on this coordinate grid and we say that that opposite is the y coordinate of this point here, well, clearly it's going to be negative. So, in fact, it's going to be negative all the way around to here, when, of course, at theta equals 270 degrees, the sine of theta will be like this. That opposite will be minus 1. We'll have minus 1 over 1. So we're going to have sine theta equals minus 1. Let's plot that on this diagram. So we can see we're going to get smaller and smaller and smaller until we get to minus 1 there. And I'm sure you can see what is going to happen now. This opposite is going to go closer and closer and closer to this particular point here on this axis. So closer and closer to the y coordinate being 0. And so at 360 degrees, we are back to being 0 again. So this is what the graph of sine theta looks like. It is oscillating, it's going up and down. And of course, we could carry on. We could go past 360. We could do this as many times as we like. But of course, we're going to be repeating ourselves. So that theta could go to 90, 180. It could go to 270, 360. But if I reversed it back around again, I mean, clearly you can see that at 450 degrees, it's going to be the same as it was at 90 degrees. So what happens is this just oscillates and goes on and on and on. So we could carry this on again. Let's go for another full 360 degrees. So it would be at 450, it's going to be 1. At 540, it'll be 0. At 630, it's going to be minus 1. And at 720, we're going to be back to 0 again. So if I join this up, this is what the graph of sine theta looks like between 0 and 720. But it will go on forever in the positive and negative direction. So that is the graph of sine theta.